Let's start with some review exercises. So first, determine the output of this. So first, when I is 0, we have that a0 of I is a0 of 0, which is 5. And then a0 of a0 of I is a0 of 5, which is, well, that's index 0, that's 1, that's 2, that's 3, that's 4, and that's 5. So a0 of 5 is 8. So then it prints 0, 5, 8. Then when I is 1, a0 of I is a0 of 1, which is 6. And then a0 of a0 of I is a0 of 6, which would be 2. So it would be 1, 6, 2. The next, when I is 2, a0 of I is a0 of 2, which is 4. So then a0 of a0 of I would be a0 of 4, which is 3. So then it would print 2, 4, 3. And then when I is 3, a0 of I would be a0 of 3, which is 7. Then a0 of a0 of I would be a0 of 7, which is 9. So then it would print 3, 7, 9. And then when I is 4, a0 of 4 is 3. And then a0 of a0 of I would be a0 of 3, which would be 7. So then it would print 4, 3, 7. Then when I is 5, we notice that 5 is not less than a0.length over 2, because this number is 5. It's 10 over 2, which is 5. So then we stop. Just remember to keep track of whether the condition is true, because the condition could be false at some point. We don't have to travel through the entire array to be done. So then the output is also shown below. Next exercise. So first we have for every int I in the A2. So basically for every element in A2. So in this case we start with 0, but it doesn't have to start with 0. So I is 0 right here. It's a specific element of A2, not the index. However, over here it's being used as an index for A1. So then A1 of I is A1 of 0, which is 2. So then the output would be 2. And then I becomes 2 because it becomes the next element of the array. Then A1 of 2 would be 6. So then it prints 6. And then I becomes 4. And then A1 of I is 0. So then it prints 0. And then I becomes 6. So then we do a1 of 6, which is 7. And then afterward, I becomes 5 because that's the next element in the array. So then we print a1 of I, which is a1 of 5, which is 9. So then it prints 9. And then I becomes 3. So then a1 of I is 8. So then it prints 8. Then afterward, I becomes 1. So then a1 of I is 4. So then it prints 4. And the output is also shown below. Here's another exercise. Print the sum of the array below and make it so that if we change it, it still works. So basically don't hard code the sum. So for this one, we need to keep track of a sum variable, set it to 0 in order to sum the elements of this array, because our variable, we can't do everything inside of our loop. So then for every element in AA, I just add it to the sum. So sum plus equals I, and then print sum at the end. And then it's 27, which is the sum of these elements. We could have also done for int I equals 0, I is less than AA.length, I plus plus, sum plus equals AA of I. Of course, we can't have both of these. We can only have one of these. And this should also work, as shown below. Now, what if it's a product instead of the sum? Well then, in that case, we need to set the product to 1, and then sum instead product times equals I, and then it would work. Similarly, the maximum, max equals, say, the first element of that thing. We want to make sure that the max doesn't start out above all of these elements, so therefore we want the max to be something like this. And then afterward, we just do if I is greater than max, max equals I, and then we print max. And similarly, the minimum of an array, if I is less than min, min equals I, print min. And it works as shown below. Here's another one. So first we have 4 arrays here, and we want the element at index 2 different times. One after modifying A4 and one before modifying A4. So first, the first time when all of them are original, we have A3 of 2, which is 4, A4 of 2, which A4 is equal to A3, so it's still 4. Similarly, A5 of 2 is still 4. And then similarly, A6 of 2 over here, it's 4. Now this is where it gets interesting. A4 of 2 becomes 5. So then you may think that it would be 4, 5, 4, 4. However, that's actually wrong. In fact, it's 5, 5, 5, 4. Now why is that? Why does A3 and A5 change with A4, but A6 doesn't? The reason is because first, when we construct A3, it points to, first, I construct an array that has elements 1, 3, 4, 7, 9, and then it points to this array. And then we set A4 equal to A3, so A4, all of a sudden, what is this thing? Well, that A3 is this thing, so we just set A4 to point to that. So then we would get the following. And then finally, when we set A5 to be equal to A4, well, what is A4 pointed to? A4 is still pointed to this array, so A5 would still be pointed to this array. And then when we do A6 equals new int 1, 3, 4, 7, 9, this time we're creating a separate 1, 3, 4, 7, 9 that's different from A3, A4, and A5. And we're pointing A6 to there. So therefore, when we access A3 of 2, A4 of 2, A5 of 2, and A6 of 2 the first time, it would be 4 and 4. However, when we access a3 of 2, a4 of 2, and a5 of 2, and a6 of 2 after we modify a4 of 2. Then now a3 of 2 is also modified to be 5 because, well, when we change a4 of 2, we change the array it's pointing to. However, a3 and a5 just happen to be pointed to the same array. So therefore, a3 of 2 changes to 5, a4 of 2 obviously changes to 5, and a5 of 2 also changes to 5. And then a6 of 2 remains at 4 because it's a different array than a3, a4, and a5. Now, let's see what would happen if I do something like a4 equals, say, 1, 2, 3, 4, 5. Then I printed the element at index 2 for all of these. Then what would happen? Well, let's see. First of all, what's different about this case is that we actually create a new array instead of just merely changing the array that a4 is pointed to. We're creating a new array, and then we're redirecting the pointer of a4 to this array. So then now a3 of 2 is still 5, a4 of 2 is 3, a5 of 2 is still 5, and a6 of 2 is still 4. So basically, when we're accessing an element and we change it, every array that's pointed to that array that we change will be changed. So like over here, this change when a3 and a5 were still the same thing as a4 would remain and spread toward a3 and a5. Similarly, if we modify, say, a5 of 1, let's just say, equals 0, and then I print a3 of 1, then what would happen? Well, a5 of 1 would be 0, and then as a result, a3 of 1 would be 0, as shown below. However, when I directly modify the entire array, like a4 equals new int array 1, 2, 3, 4, 5, I'm redefining the entire array. So then therefore, we're making a new array, and a4 is detached from a3 and a5, and it's when I modify a4, it no longer modifies a3 and a5 because it's set to a different array. Here's another exercise. Determine the output of the following. So first, since we see that we're modifying and accessing the arrays, specifically modifying them, it's probably best to keep track of them, as well as any additional variables. So first, a7 is 9, 8, 7, 6, 5. And then a8 is 4, 3, 2, 1, 0. And then since we're dealing with arrays, it's probably best to use this pointer format because, well, we set a9 to be a7, and that doesn't just make a9 set to 9, 8, 7, 6, 5. That's not how it works because we're setting a9 to a7. They're the same array then, so therefore they're linked when they point to the same array. So when we modify a9, it modifies a7, and similarly when we modify a7, it also modifies a9. And now finally we reach here. So the first value of I is 4 because we are looping through the elements. That's what this loop is. So therefore I is 4. So then, well, we print a9 of I. So we print a9 of 4, which is 5. So print 5. Then afterward, a9 of I plus plus. So now this number is 6. Then afterward, I becomes 3 because that's the next element in a8. So then what is a9 of 3? Well, that's just 6. And then afterward, after we print 6, a9 of I plus plus, so now this thing is 7. And now we're done with this iteration, so we go on to the next element, which is 2. And then a9 of 2 is 7, so we print 7. And then a9 of 2 plus plus, so now this thing is 8. And then, well, now I is 1. We print this element, which is 8. Then now it's 9. And then I becomes 0 because that's the next element in A8. So then we do the following. We print a9 of 0, which is 9. And then now a9 of I plus plus, so now that element is 10. And now we're done, because we're done with this iteration, and 0 is the last element of A8. There's no more things to loop through, so we're done with I. And now we're done with this loop. On to the next loop. This loop, well, we could go over it, or you could just recognize that this is just printing every element of A7, so 10, 9, 8, 7, 6. And the output is also shown below. In the last exercise, which will review everything we've learned so far, or almost everything we've learned so far. Basically, this problem will create an array, then repeatedly do one of 4 operations. Get an element at a specified index of the array, set an element at the specified index of the array to the specified value, print the array and its sum, or quit, or more detailed. This, prompt the user for an integer n, then prompt the user for n integers and save them into an array, then repeatedly prompt the user for an operation and do the operation. And yeah, and the sample output to show the format of which my output should be. So first, we need user input, so we need import java.util.scanner. And now next, we'll need to create a scanner. And then next, we need to prompt the user for an integer, so enter an integer. And then int n equals input.nextInt. And note that here we're doing system.out.print right here, because enter an integer 5, it shows up nicely like that. You could do system.out.println. Makes no big difference, it just looks a bit worse. And now, next we need to enter 5 integers, or actually enter n integers in the general case. So system.out.print enter n integers to store in an array. And then, well, we obviously need an array to store them into, so let's just call this thing, say, storage. And it needs to have a length of n, because we need to store n elements. And in order to accept as input n integers, we need a for loop. And the reason we want to use a for loop instead of a while loop is because we know that we want to execute this n iterations, and a for loop has a nice way of doing that. So now storage of I equals input.nextInt. Basically whatever the user enters becomes an element of the array. Now we're done with that part. And just to make sure it works, enter an integer 5, enter 5 integers 1, 3, 5, 7, 9. It works. And now next, we need the operation part. So first, repeat the following. Usually when you have repeat the following, well, it's obviously going to be a loop, but then what type of loop is it? I'll use a while loop because I don't know how many times I'll execute this. And inside the condition is true. I'll just put true, basically executing forever until a break statement, because I just put repeat the following without a certain condition. So then, now, I do the following. I prompt the user for an integer, basically what operation do you want to do, so this thing. I print that, and then afterward, int, say operation equals input.nextInt. And now, if the user enters 1, then we do operation 1, which is get. So if operation is 1, then we need to do the following. Prompt the user for an index. Except not from 0 to 4. Actually, it's from 0 to n minus 1. And then afterward, we need to accept the index. So int index equals input.nextInt. Then afterward, the element at index is the value. So basically, first of all, if the index is out of bounds, because we were asked to check for that, display an appropriate error message. So if index is less than 0 or index is greater than or equal to storage.length, there is no element at index then, so it's out of bounds, and therefore we should print the index is out of bounds. And now otherwise the index is within bounds, so therefore we have to do the following. Print the element at the index the user enters. So in this example, the element at index 2 is 5. So generally system.out.println the element at index is and then storage of index. And now, just to make sure operation 1 works, enter an integer, 5, enter 5 integers, 1, 3, 5, 7, 9. If we do operation 1, enter an index, 0, it's 1, 1, it's 3, 2, it's 5, say -1, the index is out of bounds. And now, if the operation is 2, and actually I'm using an else if. You could use just ifs, but then when you get to if the user enters any other integer, the last statement would be more complicated. So since these are just disjoint cases, I might as well just use else if, and at the last case use else. So here, else if operation is 2. Well, again, I still need to prompt the user for an index. That hasn't changed, so that. And if the index is not out of bounds, then we prompt the user for a value. So basically, enter a value. Then we need to accept the value. So int value equals input.nextInt. Then we don't need to print anything. We just need to set the element at index of the array to value. So storage of index equals value. And then we're done. And now just to make sure operation 2 works, enter an integer 5, 5 integers 1, 3, 5, 7, 9. So if we get 0, it's 1 right now. If we set 0 to say 7, now when we get 0, it's 7. So it works. And now next we need operation 3. If the user enters 3, then print all the elements of the array, then print their sum. So else if operation is 3, then I print the array, preferably in this format. Well, in that format, I would want to do left bracket and right bracket and in between the elements. And we'll use a for loop to print the elements. So first, I need to print the element itself, storage of I, and if it's not the last element, so if I is not equal to n minus 1, then I print comma space, because if it is the last element, as you see over here, we don't have a comma, because commas are only in between two numbers. Then we also need the sum, so we'll use this for loop to calculate the sum as well. Int sum equals 0, and sum plus equals storage I. Then we just need to print the sum, and over here sum, and then the sum. And now just to make sure the sum operation and basically the operation 3 works, if we do 3, it's 1, 3, 5, 7, 9 with a sum of 25. And now if we do something like 2, we set the element at index 1 to say 0. Now it should be 1, 0, 5, 7, 9. So yeah, and then the sum is now 22, which is correct. Now, last operation, if the user enters 4. So else if operation is 4, then it says quit. Well, how would we quit? Well, we notice that we're just inside this while loop right here. And right here, we're directly inside this while loop, not any other loop. So therefore, we can just do break. And now finally, the last thing, if the user enters any other integer, display an appropriate error message. So else print the following. Over here in this case, please enter 1, 2, 3, or 4. And now let's make sure the program works. So let's run the program using the sample output as a reference. Enter an integer 5. Enter 5 integers 1, 3, 5, 7, 9. Enter an integer 1. The index 2. The element index 2 is 5. Operation 1 works. We enter 2, then index 3, value 4. Then when we get the info, so operation 3, we see 1, 3, 5, 4, 9. Sum is 22. So both operations 2 and 3 work. Now 2, enter an index 6, index is out of bounds. Enter an integer 0, please enter 1, 2, 3, or 4. Enter an integer 4, and we're done.